Welcome to Math Challenge 448. In Math Challenge 448, we are given an equilateral triangle and a semicircle radius 10. Semicircle radius 10, and we have to find the length of the side of equilateral triangle. Math challenge for all quantitative and numerical aptitude tests. Math challenge 448. So what we do is, the center of the semicircle is marked. We join it to the top vertex of the triangle. We draw a line joining the center of the semicircle and the vertex of the equilateral triangle, and the triangle is divided into two equal halves. Two equal halves because it is an equilateral triangle. So we draw from the center a line joining the top vertex of the triangle, and the whole triangle is divided into two equal halves. That means two triangles of equal areas. Let each side be equal to n units. Capital N is the length of each side of the triangle. From center, draw radius to point of contact of the tangent. See, the side of the triangle is the tangent to this semicircle. So join the center and the point of contact. So we get the side, each side of the triangle n units, and from the center of the semicircle we are drawing a line to the point of contact of the tangent. The tangent is the side of the triangle. Now let us proceed further. Now radius is always perpendicular to tangent. Radius is always perpendicular to tangent. So n is the base. Take one half of this. The left half we are taking. The triangle has been divided into two equal halves. Now we are taking one half. So the base is n and the altitude is the radius, which is 10. The base is 10. The base is n units, and the altitude, which is the radius of the semicircle, is r, which is given to be 10 units. So r equal to 10. So n is the base, radius is 10, that is the altitude. So area of this half, one half of the triangle, will be given by half into base into altitude, half into n into 10, that is 5n. So 5n is the area of the left half of the triangle. Because n is the base, the length of the triangle, the length of the side of the triangle, n, that is the base, and the altitude, which is the radius r, which is equal to 10 units given. So half into base into altitude, half into n into 10. So half of this half, the area would be 5n. So area of one half of the triangle, 5n. Similarly, the area of the other half would also be 5n, because we divided the triangle into two equal halves. Or you can draw another radius, and again half base into altitude, it will give you 5n. So left side 5n, right side 5n, so the total would be 10n. So the total area of the equilateral triangle, that is both the left half and the right half, would be 10n. But the area of equilateral triangle is root 3 into side square by 4. There is a formula. For area of an equilateral triangle, the formula is root 3 into side whole square divided by 4. So if n is a side, then it should be root 3 into n square by 4. Root 3 into side, which is n square by 4. So the area of the equilateral triangle should be root 3 n square by 4. But this is equal to 10n. Just now we calculated the area of two halves, 10n. So root 3n square by 4 is equal to 10n. We will solve this equation and find the value of n. So we got root 3n square by 4 is 10n. Because n is not 0, we can divide by n. So dividing by n, this n square will become n, and this right side n will cancel. So root 3 n by 4 is 10, or n is 10 into 4 by root 3, that is 40 root 3 by 3. 40 by root 3, we rationalize 40 by root 3, multiply both numerator and denominator by root 3, we get 40 root 3 by 3. And now we put the value of root 3 as 1.732, and we get the value of n as 23.1. So 23.1 is the length of each side of the equilateral triangle, 23.1 units.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.